Hey, what's up, everybody? You know who it is. It's your boy, Algebra, coming to you live and direct from the studio. This time, the studio is actually sitting right here in my kitchen, representing for Team Averick today. He's not feeling very well, so I apologize for my absence, but he's a little bit more important to me than your calculus grade is. It's just facts. Having said that, I'm gonna go ahead and hook you up with a little video to talk through some of these indefinite integrals and also taking that U substitution concept a little bit farther than we did last week. If you notice right now, you're looking at this, looking at, hey, what should the U be? Should it be the X or should it be the X plus one? That's the type of situation we have to deal with is how can we actually deal with more than one X where the derivative and the antiderivative don't really play nicely together. We're going to do that in the context of an antiderivative today. Your tasks for today include taking notes off of this video. You also receive this printed out as a handout. Ignore the numbers on the side. But the second part is you guys are going to have a homework assignment, and the homework assignment is actually all review over things that we did last week. You will be turning that in for a grade. This concept that we're starting with today, we're going to keep it going tomorrow and through the rest of the week before you actually have any type of assessment over the U substitution concept as a whole. But that's enough of the intro. Let's get down to business, like they said, and move on. When I look at this particular problem, my first instinct is to deal with this part that's inside of the parentheses, and that shouldn't be any different than what we've done before. We want to set our u equal to x plus 1. And the reason why we want to do that is, again, because we want to try to help ourselves simplify that ninth power instead of dealing with x plus 1 and like drawing out Pascal's triangle to figure out the coefficients and all that. Let's just make it u to the ninth. The problem is I also have this extra x over here, so my du as a concept is going to be a little bit kind of messed up this time. That's what it's supposed to be, but why do I have an x over here? And since I have that x, what can I do to help myself out? What I can do is actually take that u value and substitute not only in for the x plus 1, but I want to solve it for x now. And the reason why I want to do that is because if I substitute out the letter x in one location, I can substitute it out in all locations. What if I put that here? So I'm actually going to do two separate substitutions all at the same time. This is what my product should look like. U minus 1 times u to the ninth du. So all of those different moving pieces. The u to the first power took the place of the x. The x plus 1 was traded out for the letter u. The du represents the dx. That ninth power still stays there. So the reason why all of that was really important to me is because now I have a situation where I have a pretty simple integral to deal with. And I say it's simple because I can just do a distributive property and make a u to the 10th minus u to the ninth du. That's like the very first day of integration. That very first day of integration, we talked about the product rule. We made this u to the 11th over 11 minus u to the 10th over 10 plus c. So now the question comes up, where did this plus c come from? And what are my boundaries supposed to be? Well, this is considered an indefinite integral. An indefinite integral is literally saying that it is not defined. For our purposes, you need to recognize that an indefinite integral means that there are no boundaries. Because there's no boundaries, there's no way for me to actually use the fundamental theorem of calculus on it to find an actual value. And that is the same reason why this plus c is hanging out here at the end of the problem. Since it's not defined for me, I don't know if this function is really talking about u to the 11th over 11 minus u to the 10th over 10 plus 5, or if that's a plus 7 at the end. And ultimately, it doesn't really matter. We're still talking about rate of change, and that c at the end stands for a constant value. And if you don't like the word constant, you could talk about it as an initial condition. When we talk about constants and initial conditions, we're basically saying this is where you should start. And now the rate of change, now the function starts to accumulate. Now the integral is taking place. That c was already there. We just needed to account for it. So my final step in this process, I have an indefinite integral, so I'm still going to have a plus c at the end. There's nothing for me to plug in, but I do need to account for the fact that I started off this problem with x's and I ended it with u's. I want you to go one more step. Plug your x plus 1 back in to this equation. Once you do this, you're done. Final answer. So we're going to be using the same process on the next couple of questions as well. But now that you've seen it once, you'll be able to do it the next time a little bit more effectively. Here we go. All right, so again, we're looking at this particular problem, and we have an x squared on the outside with an x plus 1 on the inside, and I don't really know which one I should deal with primarily. I'm going to deal with the one that's on the inside. And the reason why I'll do that is because it's on the inside. It's kind of grouped apart from everything else. And so I'm going to set my u value, substitution, equal to x plus 1. That means when I perform my du, I need to have 1 dx. And as we talked about in the previous example, it's not good enough to just substitute out the x plus 1 this time. We also need to deal with the fact that I have x squared in this problem. So I'm going to solve this for x. X is equal to u minus 1. Well, that also seems convenient to me because now I can take out that x squared and put in u minus 1 squared. Again, a pretty comfortable thing for me to deal with in the grand scheme of things. This is what I get, u minus 1 squared times u to the 1 half du. So all pieces have been accounted for. Got the yellow part. I've got the blue part. And I've got the green part as we defined directly below it. So how can we keep on going? Well, since you only have a second power, that's a pretty easy thing for you to do multiplication-wise. U squared minus 2u plus 1 times u to the 1 half du. Distribute again. This becomes u to the 5 halves minus 2u to the 3 halves plus u to the 1 half du. Power rule again, and we can just keep this thing rolling. Power rule says you add 1 to the exponent and then put that same value to the denominator. A lot of you don't feel necessarily comfortable with putting a whole fraction down on the bottom of an expression. And if that's the case, that's okay. We know how to deal with that using multiple steps. This is what I should end up with. It goes up to the 7th power, or excuse me, 7 over 2 for the power. But when you put that on the bottom, it actually puts the 2 on the top and the 7 down below. Same thing is going to happen again. It's going to be minus, there's already a 2 there, so that's why it's going to be 4u to the 5 halves over 5. The next one, 2u to the 3 halves over 3 plus c. Final step is plug back in the x plus 1 for all of those u values that we were given in our last step. 2 x plus 1 to the 7 halves over 7 minus 4 x plus 1 to the 5 halves over 5. 2 x plus 1 to the 3 halves over 3 plus c. So again, that last piece, that plus c at the end of this expression, is absolutely important. You have to have it there because we don't have boundaries defined for us. Let's keep this thing rolling. We're going to do one more problem. I'm going to stop for today and then allow you to work on your homework. Yikes. My gird. What do I do if I have an x plus 1 that's complicated, and I also have this parentheses that involves x plus 2? Same thing as what we did before. Identify a u to begin with. Let's start with x plus 1. My du is 1 dx. I've got those pieces taken care of. This also means that my x value is u minus 1. Okay? So if I have all of these things working for me, I can start to do some substitution. I'm going to take this value, plug it in right there. This whole concept is taking that second parentheses place. I get something that looks something like this. U minus 1 plus 2 times u to the 1/4 du. Do some algebraic wizardry to turn it into this. Distributive property. And now we have an integral that we can deal with. Computing this integral, antiderivative to get rid of that integral sign. U to the 9/4 over, and again, this is where we have to do that wizardry. It should be 9/4, all of that stuff on the bottom. So we're going to put the 4 on top, 9 goes on the bottom, plus 4u to the 5/4 over 5. And you're done. Yay! Psych. Plus c. If you forget the plus c, you're wrong. Remember, this is an indefinite integral, which means that we have to have that plus c to hold that spot. We don't actually know what function we were given to start this process. We have to account for all the possibilities, all the possible constants that are added, all the c's. So one last thing that I want you to do is go back and plug those x's in. Here is my final result. I'm going to be putting in the x plus 1 back into the problem as it was given to me originally. Voila. So this has been your boy Algebra, live and direct from the studio. We'll say thank you for your attention. Thank you for your time. Hold on to this paper because this is where we're going to be starting off our notes tomorrow. The rest of the period today, you have to work on a review assignment over last week's material. Peace.